Okay. All right, so the first one we're gonna be looking at is the magnesium. Now I have a roll of magnesium. As you can see, it's gray. Hopefully you can see that. Is that seen? Yes, it is. Okay. So you guys can see this here. Now this is not very well polished, but it is gray silver. If I take a little bit of steel wool to it, you get it really nice and shiny. And this is actually, it's a, this one's actually safe enough to handle here. Sometimes they use it like an alloy and with other metals, like with aluminum, to make like bike parts and airplane parts. Now, it is a fairly reactive metal. Typically, the way they go about determining the reactivity is they see how does it react with water. Typically cold water, hot water, like a weak acid, a strong acid. And I'm just working with cold water and a weak acid. And for the weak acid, I'm using vinegar, which always makes me start craving French fries and
I love vinegar.
the fair fries and
I don't know why you do this. I love vinegar.
you need fair fries with lots of vinegar and ketchup.
I swear, when there's no food in the house, I just think fries.
Yeah, there we go.
My grandpa does that, but it's more of a colorful than
Okay, now, so first thing I'm going to do is I'm going to break apart this magnesium. And again, magnesium is actually very soft. If you get thin enough, you can actually just tear it. I'm just going to bend it and break it apart in half. And I'm going to put some into regular water. And if you notice, where does it go?
The bottom.
The bottom. So we can talk about the density of it.
It's more dense than water.
Okay, it's more dense than water. Is that showing up? Yes, and okay, there's the lens. Okay. Now, if you look at it right away, you see a whole lot of things, anything going on really.
Nah.
Not really.
Put some bubbles on, that's about it.
And it will react, but this is about the rate at which it goes at.
So, what will it do eventually?
Well, it is reacting with the water, but it's just a very slow reaction. If you look right on the edges of it, you can see like little tiny bubbles. You see them? And you see a little bit more bubbles being formed. See?
Oh, yeah. I see the top.
Okay. And I had in the last class where it was, there you go. Okay. I had in the last class here where it actually got enough bubbles on it to the point where it started rising up, became buoyant enough. Now, we're going to do the same thing. I'm going to put the other one in vinegar. All right. So, vinegar. And almost right away, you see the difference.
Pretty sweet.
Considerably faster.
That'd be awesome.
Okay. Sometimes getting enough bubbles on it to make it buoyant.
So what will it eventually do? Like,
It'll dissolve. It's making right now. It's making the compound called magnesium acetate, which you guys will learn how to figure that out. But the gas being produced from this is hydrogen gas.
is it getting
And
hotter?
it does generate heat, but hardly anything quite noticeable here between the two of them. The one on the right is, the clear one is water and the other one is vinegar. And if you do this side by side,
Yeah, it's definitely.
and perhaps by the end of this period, the one in vinegar will probably practically disappear. The one in water, it'll disappear, but it may take several days.
Weird.
So just a lot slower reaction. Now, if I were to heat up the one in the water, put it in hot water, it will be quite a bit faster. Not quite this fast here, but it will be quite a bit faster. All right, so now, next one. I like to get start wearing gloves now. So, next one, I'm gonna go to calcium. So one element down on the periodic table, group 2. What's gonna happen to this reactivity?
It's gonna go up.
Okay, reactivity should start going up. Now, I don't have any fresh thing of calcium. It is tarnished. If I were to basically sand it off, it would be kind of a gray silver color to it. Right now, it's just kind of has kind of a whitish coating on the outside of it, and that's basically just like oxidation on the surface. It's kind of like rust. So it kind of looks like, let's see, oh, there it is, okay. That kind of looks like that, okay. So you have this very silvery color. And again, if I were to sand off this piece here, it will be a typical gray silver color.
Wait, so is it like, will it do something to your skin if you touch it with your?
Not too much. If I hold on to it for too long, it can.
I heard the calcium. I don't know.
Now, a lot of times when people think, well, you need more calcium in your diet, this is metallic calcium. What they're talking about is a calcium compound. Calcium that's combined with something else. Typically it'll be like calcium carbonate, like chalk, limestone. If you have hard water and you get that white crusty stuff on the outside of your faucet, that's typically like a calcium carbonate. So what I'm gonna do is I'm gonna put a little bit, I'm gonna take those smaller fragments, put that into the water. There. You'll notice almost right away, this thing starts bubbling. And if you compare that to the magnesium, it started almost right away. See that? Now, I'm gonna set this down here for a moment. So, now look at the bubbling here. Let's see, come on, let's see it. Okay. Now, here's the thing. Here's magnesium in water. That's calcium in water. See the steam coming off of that? That thing has gotten hot.
So how hot, like how high is that? Like,
Come up and touch it.
touch it?
Just be cautious. Move it out here, just move more towards the center here. It's hotter than what you realize.
It is kind of warm. Oh yeah. It already stopped.
Hmm?
It already stopped.
And yeah, that's the other thing too, is that it's almost completely done reacting. Compare that to the magnesium, which is still going. Okay. So, what do you think is going to happen when I put this in vinegar?
It's gonna go quick.
Okay. So, magnesium and vinegar, a weak acid. Is that showing up?
Oh, nothing's gonna
Hey,
happen.
hey, hey.
Why is it?
Where you at? Where you at? Somewhere. There we go. Okay. There we go.
So nothing happened, or not a lot happened. Alright, yeah, I feel like it's gonna
So
take
here's
off in a
the
minute.
calcium and vinegar. So showing up on the video.
It's definitely gonna take off in a minute.
Problem is, it has this kind of a thick oxidation layer on the outside,
Oh, yeah.
but once it gets through that, cool,
That's done.
yeah, it's still going.
What bubbles can we just be on?
Should be generating. And it's getting warm.
So now it's less dense than water?
Hmm?
Is now it's less dense than water?
Well, it's
Or
buoyant,
is the bubbles are
all the
making it
bubbles. And I think there might be a little bit of soap in the test tube, so it's foaming up. Someone did a nice job of cleaning the test tubes, they just didn't do a very good job of rinsing them out. That was probably me.
That's pretty sweet though.
Mm-hmm.
Salt, vinegar, and calcium make a cool
Yeah.
combination.
So when they say you need more calcium in your diet, you definitely don't wanna swallow one of these things. First of all, the heat generated off of this thing here is quite a bit. And
What would that do to your body?
pure calcium by itself can be toxic.
Wait till it comes where it kills you?
What's that?
Wait till it comes where it kills you?
If you have enough of it, yeah.
Everything's toxic.
Yeah, everything has a toxic level
That's
to
true.
it. Water even has a toxic level to it.
Yeah, you basically drown yourself if you drink too much.
Well, yeah. And the same thing like table salt. I think it's roughly about a pound of table salt is lethal. So,
You know how hard it'd be to eat that much table salt?
yeah.
It'd be such a painful experience.
You really gotta like salt. So now, if you look at the chart, so we looked at magnesium, we looked at calcium, okay? So now, we're ready to go to group one. What should happen?
They should get more
They
reactive.
should get more reactive. So of those two, between sodium and potassium, which one should be more reactive?
Potassium.
Potassium should be. So we're gonna start with sodium first. Okay, gotta leave the grand finale. All right, so I'm gonna move this.